Good afternoon, everyone. So today I will be talking about spammers performing BGP hijacks to send spam and remain stealthy, and about a tool called SpamTracer that we have developed to track those spammers. So let's just quickly start with a brief introduction. So BGP hijacking is caused by the injection of erroneous routing information into BGP. And this is possible because, well, there is still no widely deployed security mechanism to prevent this. The effect of a BGP hijack is then either a black hole of the victim network or the hijacker can act as a middle. So we also know that BGP hijack incidents occur regularly in the internet, but those incidents, well, most of them can be attributed to router misconfiguration or an operational fault. Like the most famous one is probably the hijack of part of YouTube network by Pakistan Telecom, but there are many others. What we're interested in our case is whether BGP hijacks are also performed in preparation of other malicious activities like spam. So this work started with a conjecture. The conjecture is that spammers would use BGP hijacking to send spam from a stolen IP space and remain stealthy. So this phenomenon was really introduced a few years ago in a research paper which described short-lived routes that is lasting less than a day to unannounced IP space that were correlated with spam. But in fact, while such phenomenon does not necessarily imply hijacks. And there are also anecdotal reports on mailing lists like, of course, NANOG. And if spammers really behaved this way, this would have really serious effects. First, it can lead to misdistributing attacks launched from hijacked networks due to hijackers stealing IP identity. And second, spam filters still heavily rely on IP reputation as a first layer of defense, so this would have an impact on their effectiveness. So when we started this work, we really wanted to answer this question, flyby spammers. Is it really a reality, or is it just some kind of myth? So the objective of this work was really to validate or invalidate on a large scale this conjecture about flyby spammers. And if it turns out to be real, then this has a prevalence of this phenomenon. So to do that, we have developed a tool called SpamTracer, which basically collects routing information about spam networks, from which we then extract some normal routing behaviors and then try to detect BGP hijacks. So the assumption behind SpamTracer is that when an IP address block is hijacked for stealthy spamming, a routing change will be observed when a block is released by the spammer to remain stealthy. And so basically what we do is we collect BGP routes and IP trace routes towards spam networks just after spam is received, and then look for a routing change from the hijacked state of the network to the normal state of the network. So here is the system architecture. It's quite simple. The input to SpamTracer is just a live feed of spam received at Symantec Cloud spam traps, from which we extract spam-set IP addresses. When we see an IP address from a bug-on IP address block, we consider this, of course, very suspicious, so we monitor it. Then each spam network is monitored for 1 week after spam is received. So we collect BGP routes and IPS trace routes. The IP2S mapping is performed using live BGP feeds. Then we extract a bunch of BGP and trace route anomalies that we further use to detect hijackings. So detailed analysis of data collected between January and July 2013 led to the identification of 29 hijacked IP address blocks. As you can see, the hijacks, the distribution across time is far from uniform. And from the different address blocks hijacked, we extracted the following signatures. So the hijacked networks were dormant IP address blocks. That is, by the time the networks were hijacked, they hadn't been left unadvertised by their owner. They were also advertised for a rather short period of time. And they were also advertised from an apparently legitimate origin AS, but via a presumably legitimate upstream AS. So this kind of signature has already been described before. And in our case, we can see that all hijacks match this signature. So furthermore, in practice, we observed hijack duration between 30 minutes and 20 days, an advertised periods between 1 month and 9 years, and also only a limited number of illegitimate upstream ASs hijacked to. So for the hijack duration, the first observation of flyby spammers reported hijack lasting at most a day. Here we can see that hijacks last from 30 minutes to 20 days, with most of them lasting at most 4 days. So most hijacks were rather short-lived. Now, we can also see that most hijacked IP prefixes were left unadvertised for a very long period of time, as most of them at least a year. And also, additionally, some IP prefixes appear to have never been publicly advertised before they were hijacked. Now, to further illustrate the routing and spamming behavior of those flyby spammers, we consider a few case studies. So this figure first shows the temporal correlation between BGP announcement and spam. We can see, for example, that the IP address block on the top of the figure was routed only 1 day during which spam was received from it. Then to further assess the impact of spam sent from short-lived hijacked networks on some spam setter blacklist, we extracted the records for the hijacked IP address block from some spam setter DNSBLs, so spam house SBL and drop, UC Protect, and Manitou. And we can see that for these case studies, for these 10 IP address blocks, only 2 of them had spam sources blacklisted at the time of the BGP announcements. So what this figure shows is really strong temporal correlation between BGP announcements and spam, and also the short-lived nature of hijacks. Then, furthermore, when a spammer wants to do BGP hijacking to send spam, then he needs to set up his own machines to be able to assign them IP addresses from the hijacked IP address blocks. So this is actually incompatible with spam bots, which are actually compromised hosts, which are already hosted on some corporate, academic, or home network. And our spam feed actually provides the spam botnet responsible for sending spam. And so it's based on some known spam botnet signatures. And interestingly, no spam botnet signature match the received spam. So this also suggests that the spammers that we observed actually set up their own machines. Finally, a lot of scam websites advertising the received spam emails were also found to be hosted on the hijacked networks, which shows that spammers really took full advantage of the networks under their control. So, how effective is this spamming technique? Well, out of the 29 hijacked IP address blocks, 6 were found to be listed in UC Protect and Manitou. 13 were listed in spam house SBL and drop. Drop is supposed to list hijacked IP address blocks, even though little is known about the listing policy. 29 of them were observed only once during the time period of the experiment, which means that spammers never hijacked the same IP prefix twice. So from all these observations, we can conclude that flyby spammers seem to manage to remain under the radar. Now, we also looked at the networks that were targeted, and we found that all hijacked IP address blocks were assigned to a different organization, that is, that a different owner. And out of these 29 organizations, 12 were found to be dissolved, very likely out of business, while the remaining 17 were found to be still in business. And so from this, we can say that flyby spammers seem to simply target dormant IP address block, regardless of their owner still being in business or not. Now, quite interestingly, we observed several hijacks being performed in groups of 2 to 4, all hijacks in a group starting and ending at the same time. During several days, there were also always at least 2 IP prefixes hijacked. And we believe from this temporal pattern that those hijacks actually have a common root cause. So Now this is how this temporal pattern looks like on the timeline. You can see it's quite interesting. So SpamTracer was built upon the assumption that flyby spammers perform short-lived hijacks. And with us look specifically for such hijacks, this is the reason why each spam network was monitored only 1 week after spam was received. But then what about long-lived ones? Well, we know that in fact they happen also. There was a case that we studied thoroughly in 2011. A Russian telecom company got several of its prefixes hijacked for 5 months for spamming. But the problem is those hijacks are less straightforward to detect. In fact, a spam network which is routed for only a few hours or days is immediately much more suspicious than a spam network routed for several weeks or months. And such hijack also seem to defeat the assumed purpose of evading blacklisting after a few days even, or a few weeks, and of course a few months. A spam network will likely appear in many blacklists. And while we are currently working on updating our framework to better detect those cases. Now, in practice, what can we do to defend against these flyby spammers? Well, in the observed hijack cases, we've seen that spammers did not tamper with the origin AS of the IP address block, making them look like they were actually used by the legitimate owner. Instead, they advertised them via illegitimate upstream ASs. So there is a system framework meant to secure BGP, relying on an RPKI, which has been in development for many years now, and is probably the most promising solution for now. And it aims at preventing any type of hijack via secure route origination and secure route propagation. So the problem is that while secure route origination is now being more and more deployed, the secure route propagation is still at a too early stage. So there's basically no way currently to prevent flyby spammer hijacks. So the solution for now is just to encourage owners to return and also help RRIs to reclaim dormant IP address blocks, and because this is what spammers target. And also use some detection systems to mitigate the effects of these attacks, for example, by feeding IP-based reputation systems with a list of hijacked IP address blocks. So to conclude, while the observed flyby spammer cases show that this phenomenon really happened, though it does not currently seem to be a very prevalent technique to send spam, for example, compared to botnets. And however, it is also it's important to detect those attacks because hijacking IP address blocks hinder traceability of attackers and can lead to misreputing attacks when responding with possibly legal actions. Also, there is a lot of effort in improving the reliability and quality of internet routing registries. And in fact, hijacks just prevent any traceback, so they completely defeat this effort. Now, a few words on the perspectives. Well, we would like to provide an interface for network operators to query identify hijacks, because I think it's they would be interested in that. We would also like to actually collaborate with routing internet registries and also internet service providers to help mitigate those hijacks, because these are the ones who have the means to do that. And finally, we have an ongoing collaboration with the French Research Institute and a German university to build a comprehensive system for detection and investigation of malicious BGP hijacks. So thank you very much for your attention. It's now time for some questions and hopefully some answers.
Tony Tauber, Comcast. When you said, going back a couple of slides, that illegitimate illegitimate ASs upstreams were mostly what you saw, what do you mean by that? Specifically.
Are you referring to a specific slide?
Yeah, closer to the end. No, toward the end again. Just a few from the end. Illegitimate upstreams is what I was asking about. No, there.
Okay.
Illegitimate.
Yeah.
Just like, could you just be clearer?
How we found these were illegitimate?
Yeah, and would, is it a case where per prefix filtering would inbound would have helped or not?
So first, we found that they were illegitimate for different reasons, like they were not used for as upstream ASs for any other non-hijacked IP address block at the time. Some of them were also reported, for example, by Spam House as being involved in hijacks. These autonomous systems also refer to organizations that were also dissolved, so they were not supposed to be used anymore, and different features like this. And for the second part of the question, I didn't. So what about prefix filtering? I don't know what you mean.
I mean, I was wondering if prefix filtering would have helped. I mean, so it seems that some carrier of some legitimate standing at some point is turning up an adjacency to an AS that's of ill repute and accepting anything from them. Is that basically it?
What we believe is that either the hijackers, spammers found a colluding ISP to peer with, or that simply they managed to advertise those prefixes to some ISPs which actually don't really care about what their customers advertise. So, yeah.
Thanks.
You and then the rear mic.
Hi, Doug Montgomery Nest. It wasn't clear to me whether you're only looking for hijacks in dormant space, or you're saying that you're looking across all space and only seeing
No,
them.
we actually look for any type of hijack, but we actually only found very, I'd say very suspicious, malicious cases involving dormant IP address blocks.
Hi, TJ Knifton. So you mentioned collaborating with RARs and ISPs. What about providing a signal to RBLs about address space which has been dormant or is being advertised by a new AS for some period of time, so that I, as an MTA operator, can decide I don't want to accept mail from an address block which has freshly been advertised by an AS?
This is another, option, yeah. I just thought about RARs and ISPs because, they have an obvious role in managing and also effectively routing IP resources. So, but it's true that any mean to prevent those prefixes from actually being used is good and should be.
Yeah, not necessarily to prevent them from being used, but to give that option. So programmatically, I can say, I don't want to accept mail from anything that's new.
Yeah, you're right. Thank you.
Jeff Houston, obsessive compulsive. When I looked at this myself, I was looking at the amount of time the prefix had been dormant before it reappeared, and hoping there was some kind of signature in the dormant interval. Did you find that these spammers prefer to reuse a space almost immediately after it's been withdrawn, or do they wait for a day, a week, a month, or it's just random? Did you look at the dormant interval?
We looked at the dormant interval, and it's actually this. This. So what we've seen is that most IP prefixes were left dormant for quite a long time. It's mostly more than a year. So this gives spammers quite a lot of time to just found them. They don't necessarily, they don't particularly target prefixes which have just disappeared from the routing tables.
So if you wanted to tie this to the previous question about feeding into RBLs,
Yeah.
Is that kind of distribution a strong clue?
This might be one of the feature, but well, of course, it might be included. I mean, it might be part of like system or criteria to consider a prefix as suspicious, but it should of course not be the only one, because there are some cases where of course like I think the minimum is just 1 month, so it can be used, but it's also not not as just a single feature, of course.
Thanks.
Other questions?
No further questions. Thank you very much.
Thank you.